Welcome to Fabric Monday. Today we'll talk about running T-SQL in Python notebooks. I'm not talking about Spark SQL. Spark SQL we can run in PySpark notebooks. This is no news at all. But running T-SQL in Python notebooks, this is new. This is absolutely new. Let's see how it works. Here I have a notebook. The notebook is not linked to any data source because it's not needed. For this it's not needed. But one thing is special about this notebook is the language on the notebook. It's a Python notebook. It's not a PySpark notebook. This feature doesn't work in a PySpark notebook. It's a Python notebook. The method that we use to run a T-SQL query is to use a magic command. Magic command called T-SQL. Like this. This magic command has many parameters. Artifact. Artifact is the name of the object. The name of the object we use to run. In this case, it's a lakehouse. It's my lake. We need to specify the type. If we don't specify the type correctly, we will not locate the object, and it will fail. It is possible to run this over different workspaces, so we can use workspace as parameter. And finally, we can get a result for the Python code, specify a bind, and define the name of a variable. This means this result will be put in a variable called df2. And we have many different types. For example, here I'm using the type lakehouse. On the second example, I'm using the type warehouse. Besides that, we can also use the type SQL Database. It's also possible. There is a reference about some of these executions here in this link you see at the side of my screen. Let's execute this example. The execution of the query has a result, an immediate result which is displayed in the output of the cell. But the output is also set to a variable, in this case the df2, which I'm using only to display, and I can see the same result. The same for both executions. So in this case I'm querying a lakehouse and a data warehouse. Different objects, different elements, queried using T-SQL. This opens many new possibilities in relation to the development and query of data sources in the notebook. One question pending to answer is, why only Python? Why this feature is only available in Python notebooks and not in PySpark notebooks? There is an important reason for that. Let's talk about Python notebooks. They don't create a cluster. PySpark creates a cluster to deal with big amounts of data. Python notebooks don't create a cluster. Check this image from a Python notebook. It runs in a single server and not in a cluster. It's different than a PySpark notebook. And the server is smaller than the full PySpark server. The server for a Python notebook has only 2 cores. It's smaller. What does all this mean? It means it costs less use. Yes, it costs less use, but has lower power of processing. So again, why is this feature only in Python notebooks which have lower power of processing? Because the SQL query will be sent to a SQL endpoint or to a data warehouse, and both of them already have a clustering system behind them. In this case, we have a Python notebook sending SQL queries to a system which already have a clustering behind it. If it's a SQL endpoint from a lakehouse, a Spark cluster will be created by the SQL endpoint. If it's a data warehouse, there is an architecture called Polaris that ensures this online scaling. So the SQL on the target will ensure the scaling in a cluster and the power of processing. The notebook itself doesn't require the processing power. It's not dealing with a huge amount of data. It will deal only with the result of the query. It will manipulate a bit the result of the queries, which may be small. In this case, executing this kind of content in a Python notebook costs way less than executing this in a PySpark notebook. Many times it may not be a good idea to query SQL endpoint or data warehouse from a PySpark notebook because the notebook has a cluster and you are querying another cluster, so you are expanding a lot in this case. Thank you very much for watching and see you next week.